In the domain of science and significant unique experiences, the topic of what existed before the huge explosion has ignited discussions and interested scholars for hundreds of years. This great inquiry does not just test how we might interpret the universe, it challenges the limits of human knowledge. Envision standing at the edge of existence, looking into the vast unknown, and contemplating what lay there before our universe was conceived. The event of the enormous detonation marked the beginning of history, space, and all that we know. Yet, was there a moment before this? Could it have been a state of nothingness, a silence before the grand assembly began? If so, was it truly nothingness, or could something far more mysterious have existed before time itself? As we delve further into this question, science takes us on a journey beyond the universe's origin into ideas that challenge our understanding. Physicist Brian Cox, known for his contributions to understanding the wonders of the universe, suggests that something remarkable could have existed before the enormous detonation. He challenges us to rethink our perception of reality and existence. In this exploration, we will unravel the science, the theories, and the profound secrets that could explain what existed before everything. We will investigate ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astound you, yet they could also offer new insights into our place in the universe. Get ready to dive deep into a world beyond imagination, where the unknown still lurks in the shadows, leaving researchers awestruck and sometimes unsettled. Let us examine what existed before the enormous detonation and why these theories challenge everything we thought we knew. The enormous detonation, a starting point. To value what could have existed before the enormous detonation, we must first grasp what the enormous detonation itself was. The enormous detonation, as described by science, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to pave the way for the formation of all matter, energy, and forces. When we gaze at the night sky, we see evidence of this hot beginning, with galaxies spreading out from a single point. But why did this happen? And was there a time before this dense, hot beginning? Cosmic inflation and the multiverse. According to the theory of cosmic inflation, there indeed was a before, and it was far from empty or quiet. Cosmic inflation proposes that before the enormous bang, the universe was in a state that was cold, empty, and free, a vast vacuum. However, it was not entirely void. This vacuum contained immense energy that fueled the rapid expansion of space itself. This expansion, known as inflation, happened so quickly that it set the foundation for everything we know in a fraction of a second. Space expanded at incredible rates before slowing down, converting energy into particles and forces, thus creating the enormous explosion. But what was the nature of this energy? Why did it suddenly act to create the universe? And why did it stop? Scientists suggest that this endless expansion created patches of the universe, each undergoing its own enormous bang. Imagine a fabric stretching infinitely with tiny bubbles forming, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests there may be countless Big Bangs and an infinite number of universes. The nature of nothingness. The concept of nothingness before the enormous detonation is theoretical, not absolute. Even if we strip away all energy, particles, and radiation, the universe would not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and forces intricately intertwined. Even in its emptiest state, space would still generate new forms of energy. Dark energy, multiverses, and cyclic cosmology. Dark energy, a mysterious force driving the accelerated expansion of our universe, may have played a role before the enormous detonation. Some theories suggest that dark energy, in a much stronger state, might have fueled the inflationary phase, causing rapid expansion. Could dark energy have created the conditions for the birth of our universe? Could it be the silent architect of inflation, or even the true beginning of everything? Quantum gravity and loop cosmology. Delving deeper into the origins of the universe, Some physicists turn to theories of quantum gravity, which attempt to unify general relativity and quantum mechanics. One such theory, loop quantum cosmology, proposes that the enormous detonation was not the beginning but a bounce. According to this idea, the universe may have existed in a previous phase, contracting to an incredibly dense point before expanding again. This big bounce replaces the concept of an absolute beginning with a cyclical process. Hints supporting some of these theories might already exist in the cosmic microwave background, CMB, the faint radiation left over from the early universe. The CMB provides a snapshot of the universe when it was only about 380,000 years old, offering clues about its origins. Certain anomalies in the CMB, such as unexpected temperature fluctuations, have been interpreted as potential remnants of events preceding the enormous detonation. These imprints could provide insights into a previous universe, a bounce, or interactions between our universe and others in a multiverse. The quantum realm, fields and fluctuations. Quantum mechanics also plays a crucial role in understanding what might have preceded the Big Bang. In the quantum realm, the concept of nothingness becomes even more complex. Quantum fluctuations, temporary changes in energy levels within a vacuum, could have created the initial conditions for the universe's birth. Virtual particles, which spontaneously appear and disappear, are another fascinating aspect of quantum fields. Even in the vacuum state, these fields remain active, constantly generating fleeting particles. This activity suggests that the universe was never truly empty, even before the Big Bang. Philosophical implications. Exploring what existed before the Big Bang not only challenges scientific understanding but also raises profound philosophical questions. Is there a definitive beginning to existence? If time itself began with the Big Bang, what does it mean to discuss before? Are we part of a greater multiverse? If our universe is one among countless others, does it hold unique significance, or is it merely one of many? What is the nature of reality? Concepts like the multiverse and quantum fluctuations challenge our perception of what is real and tangible. The fractal universe and eternal cycles. The idea of a fractal universe, where each Big Bang sparks a new universe, suggests a limitless cycle of creation and destruction. In this model, existence has no ultimate beginning or end, only perpetual regeneration. Cyclic cosmology, quantum gravity theories, and eternal inflation all converge on the possibility that the universe is part of an infinite continuum. If true, this reshapes not only our scientific understanding but also our sense of place in the cosmos. Moving forward, science continues to probe the boundaries of the known and the unknown. Advances in observational astronomy, particle physics, and quantum mechanics may one day provide definitive answers, or at least narrow the possibilities, about what existed before the enormous detonation. Until then, the search for answers inspires new theories, challenges old paradigms, and expands our understanding of the universe. What lies beyond the edge of existence remains one of humanity's greatest mysteries, inviting us to keep questioning and exploring. Exist in the grandiose microwave foundation, CMB, the weak luminosity of the enormous detonation. Researchers concentrate on designs in the CMB to look for peculiarities that could indicate a universe before our own. For instance, a few scientists hypothesize that certain highlights in the CMB may be scars from occasions originating before the huge explosion. These designs, when never affirmed, could give direct proof of a past enormous cycle or communications between universes. In a multiverse, challenges to figuring out before the huge explosion. Notwithstanding these captivating speculations, the question of what existed before the large bang remains one of the most difficult. In science, the actual idea of before is complicated, as time itself began with a huge explosion. Without time, our customary comprehension of causality breaks down, making it hard to define what before implies. A few scientists argue that the inquiry is inherently unanswerable, as our ongoing physics cannot test past the peculiarity of the enormous detonation. Others believe that new breakthroughs in quantum mechanics, string theory, or other emerging fields could eventually provide answers, philosophical and otherworldly suggestions. The quest for what came before the enormous detonation isn't simply a scientific undertaking. It also addresses significant philosophical and profound questions. Many traditions, both old and modern, have wrestled with the idea of a universe without a beginning or end. For some, the concept of an eternal multiverse aligns with spiritual ideas of endless creation. For others, the idea of a recurrent universe resonates with philosophies of renewal and resurrection. No matter one's perspective, these theories challenge us to re-examine our place in the universe and our understanding of existence itself. The future of investigation. As technology advances, our ability to test the mysteries of the universe will continue to grow. New telescopes, particle accelerators, and theoretical structures may help us uncover clues about the universe's earliest moments or even its antecedents. Meanwhile, the question of what existed before the huge explosion remains one of the greatest mysteries of science. It reminds us of the limits of our knowledge, yet also inspires us to keep pushing the boundaries of discovery. The idea of cyclic cosmology. Perhaps the ultimate answer lies not in finding a definitive beginning, but in embracing the complexity and wonder of the universe, a timeless mystery that will continue to captivate and challenge us for generations. This model of the huge explosion is certainly not a one-time event, but may be part of an undying cycle where universes collapse, decay, and then recover in another cycle. This hypothesis suggests that our universe may have been restored from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would suggest that there was never a true beginning, but rather an immortal series of universes emerging, creating, and restoring themselves over and over. Gravitational waves and the early universe. Gravitational waves are another fascinating concept that could shed light on what existed before the enormous detonation. Discovered in 2015, they are ripples in space-time caused by massive objects like black holes or colliding neutron stars. Could gravitational waves provide information about the birth of the universe? Some physicists propose that gravitational waves originating from the time before the huge explosion may offer insights into the state of the universe before inflation began. Gravitational waves from the early universe could leave traces that might help us determine whether the huge explosion was truly the beginning or if there were cosmic events before it that we do not yet comprehend. Philosophical implications. As scientists continue to explore the vast expanses of space, the question, what existed before the enormous detonation, remains profound. Current theories point to quantum mechanics, multiverses, and cosmic inflation, bringing us closer than ever to unraveling the fundamental mysteries of the universe's origins. While the complete answer remains elusive, our understanding evolves with every new discovery. As we delve deeper into these theories, we may consider how they fit together to present the bigger picture, the true nature of existence itself. Until then, we are left with a mystery that drives science and pushes us into unknown realms, far beyond what we currently comprehend. As we dive deeper into the mysteries of what may have preceded the Big Bang, we encounter increasingly complex questions about the nature of reality itself. Time, space, and matter, as we understand them, are fundamentally tied to the moment of the Big Bang. If time did not exist prior to this event, our entire framework for understanding causality becomes irrelevant. Some theories suggest that time might not have a single starting point, but instead could be cyclical, looping endlessly without a definitive beginning or end. This raises profound implications, not just for physics, but for our understanding of existence. If the universe has always existed in some form, the notion of creation itself may need rethinking, along with traditional scientific and philosophical assumptions. Emerging theories and possibilities. 1. Quantum cosmology. Quantum mechanics offers a potential avenue for understanding the universe before the Big Bang. Some models propose that quantum fluctuations in a pre-existing quantum field could have triggered the Big Bang. These fluctuations may hint at a realm where time and space, as we know them, were meaningless, replaced by probabilistic states. 2. Multiverse hypothesis. The concept of the multiverse posits that our universe is just one of countless others. In this framework, the Big Bang could be a localized event within a larger, eternal multiverse. Collisions or interactions between universes in this multiverse could even create new Big Bangs, leading to the birth of new universes. 3. String theory and higher dimensions. String theory suggests that the fundamental building blocks of reality are not particles, but vibrating strings existing in higher dimensional spaces. These extra dimensions may hold clues to the nature of the pre-Big Bang universe. The collision of branes, multidimensional surfaces, in higher dimensional space could explain the Big Bang as a massive energy release. 4. Eternal inflation. Another theory, eternal inflation, proposes that the universe is in a constant state of expansion, with regions periodically collapsing into Big Bang-like events that form bubble universes. Our universe would then be one such bubble in an ever-expanding cosmic foam. The limits of science and understanding. Despite these compelling theories, there are limits to what science can currently test or observe. The singularity at the heart of the Big Bang represents a breakdown of the known laws of physics. Without a framework to understand this singularity, questions about what preceded it remain speculative. Furthermore, the tools required to probe such mysteries, advanced telescopes, particle accelerators, and quantum experiments, are still in their infancy. Each new discovery, however, provides incremental progress toward answering these grand questions. The intersection of science and philosophy. These explorations inevitably intersect with philosophical and metaphysical inquiries. If time and space are not absolute, what does that mean for our perception of existence? Does the universe have an inherent purpose, or is it the result of random, eternal processes? Many spiritual and philosophical traditions have long grappled with similar questions. The notion of a cyclical universe aligns with ideas of reincarnation and eternal cycles found in Hinduism and Buddhism. Similarly, the idea of an infinite multiverse resonates with beliefs in limitless creation and renewal. The road ahead. As humanity advances its understanding of the cosmos, we will likely uncover more pieces of this cosmic puzzle. Whether through direct observation, mathematical breakthroughs, or entirely new paradigms, our quest to understand what existed before the Big Bang will continue to push the boundaries of science and imagination. In the end, the answers may challenge everything we think we know about reality. They may lead us to a deeper appreciation of the universe's complexity, beauty, and infinite potential. Even if we never fully understand what preceded the Big Bang, the pursuit itself, driven by curiosity and wonder, reflects the very essence of human endeavor.